Hi fourth graders, it's Mrs. Nobby coming to you again from my backyard. I sure hope you enjoyed the video on sound last time. This time I'm back to teach you a little bit about simple machines, which falls under the branch of physical science called physics. So what is a simple machine? It's a machine that is simple, that uses few or no moving parts to make our effort easier, our work easier. In order to explain what work is, because I'm wondering, is work the kind of thing that you do when you fry French fries at McDonald's, like going to a job, or is there another definition of work? Well, in order to answer that, I found a project that Andrew Nobby, my special guest, did in fourth grade in Miss Stewart's class. Now on the front it says work. Work is moving an object over a distance. Andrew, would you say that that's still your definition of work?
I would revise it a little bit and say work is using effort and force to move an object over a certain distance.
Very good. We'll use that definition for our purposes today when we talk about simple machines. Thank you, Andrew. Simple machines are found all around us, in our garden, in our kitchen, in our bathroom. Today, I want to start out by showing you how a simple machine works and how easy it is. So I'd like you to grab a partner if you can and a paper clip, and you can do this along with us. This is my daughter Sarah. You met her in the video last week. We're going to open up the paper clip so that we just have a straight wire. You want it to be as straight as possible for this activity. Once you have the wire straight, ask your partner to take one end and you hold one end tight. I'm going to be the person that holds it tightly, and I'm going to ask Sarah to try to turn the wire. Is that easy or hard? It's hard. Very hard to do. Now, with your partner, change jobs. So she's going to hold it tightly, and I'm going to try to turn it. Oh my gosh, it is very, very hard to do. So we're going to make a modification to this wire to help you understand simple machines. Take the wire on one end and just bend it so it looks like that. Now I'm going to hold this end and have Sarah hold it tight, and this time I'm going to try to turn first. Oh my goodness, it is so easy to turn. Sarah, let's reverse so you get a chance. I cannot hold it tight enough to keep her from turning it. Your effort is a lot less, right?
Yes.
Because we created a simple machine called a wheel and axle, and that's how simple it is. There are 6 different simple machines. The first one we're going to talk about is a lever. Now there are different types of levers, but basically it's a bar on a pivot point that does not move, and that point is called a fulcrum. So we're going to talk first about a catapult. A catapult moves a heavy object from one place to another. That's called work. So our load we're going to use with the catapult today is a marshmallow. The load sits at one end of the lever. The effort is at this point right here where I'm pulling back the catapult, and the fulcrum is right here where it will pivot. Let's see how it works. Okay, the marshmallow got from one place to another. It's not a heavy object, but it worked just the same. Now let's see what happens when the load is lighter. I've put a smaller marshmallow as our load on the catapult. Oh wow, it didn't go quite as far, but it went higher this time. Catapults are fun. Remember we made catapults in 2nd grade. If you still have yours around, you can give it a try and practice using a lever. Another type of a lever is a hammer. Watch how Sarah uses the hammer to hammer in a nail. The fulcrum, the pivot point, is her wrist. Her hand is providing the effort, and then the load is the head of the hammer where she is nailing the nail. The next simple machine we're going to look at is called a screw. Now a screw is actually an inclined plane wrapped around a pole. In order to see that, I have a special project for you guys to do. This would be really easy for you to do this at home. So you're going to need a Sharpie or black marker, a piece of paper, and a pencil and some scissors. we're gonna make a screw so you can see how it's an inclined plane wrapped around a pole. A screw is to hold two things together, like a jar lid onto a jar. Our next simple machine is called a wedge, which is actually two inclined planes back to back, coming to a pretty sharp point. So I'm going to show you a pizza cutter. You can see how it comes to a point. When you use a wedge, the downward force splits the object, just like I just split the dough in half. Now, some other examples of a wedge include a chisel, which will split wood, a nail, which also splits wood to make a hole, and this sharp object called a planer. The blade is right there, and it's used to shave pieces of wood off that look like this. Another simple machine is the wheel and axle, like we demonstrated with the paper clip. A wheel and axle is a wheel with a rod through it. When the wheel turns, the axle moves with it, just like in this doorknob, which allows the door to be opened and closed. Another example of a wheel and axle is a car tire, car wheel. So when the gas is pushed to go forward, that spins the axle connecting the two tires. It spins the axle, which then spins the wheels. A pulley uses a grooved wheel and a rope to raise, move, or change direction of a load. A great example of a pulley system is a flagpole. Does this area look familiar? It's a flagpole at Addison. So a pulley is at the very top of the ropes. And when you pull one rope, the pulley is used to change the direction of the force so that the flag will go up when this rope goes down. Now, a flagpole just has one pulley at the top, which changes the direction of the load. In a system that has two or more pulleys, those pulleys actually serve to lessen the amount of force it takes to move a load. A slide is a great example of an inclined plane. An inclined plane is a flat surface that connects a lower level to a higher level. Now, when using an inclined plane, the distance is longer, but it cuts the effort in half. I'm going to do a quick experiment to show you how the effort is less when you use an inclined plane. And in order to do that, I'm going to use a spring scale. Now, the scale that we're using is newtons, which is a unit of force. On the other side is grams. I'm going to take the spring scale and hook it to a sock filled with rice, and I'm going to raise the sock from this level to the level of the top of the slide. And that force is 4.5 newtons. Now I'm going to move the same sock full of rice from the lower level to the higher level using the slide. The reading of the newtons is right about 3, indicating that the force used because of the inclined plane is less. We've been talking all about simple machines today, but there's also a type of machine known as a compound machine, which is 2 or more simple machines put together, such as a fishing pole, which is a wheel and axle, and a lever. A stapler is a combination of a lever and a wedge, which is the staple. A can opener, which is a wheel and axle, a lever, and a sharp wedge. A wheelbarrow is a combination of a wheel and axle, an inclined plane, which is the bucket, and a lever. Fourth graders, I hope you enjoyed this video on simple machines. I'll be back next time with a video on force and motion. Don't forget to fill out the form that's above this video. Your answers will go to your homeroom teacher and to me. Before I leave you, I want to show you the bluebird nest box in the back of Addison has 3 baby bluebirds. You'll see a picture of it up on the side of the screen. Bye, 4th graders. I sure miss you.